from Faculty of Applied Science from UITM Tapa, and my name is Puteri Nur Azura binti Nazra Hakimi.
And my name is Dania binti Alif.
And my name is Nur Elia Natasha binti Muhammad Salji.
Azura, what is differentiation?
Azura, what are the techniques of differentiation?
To answer the first question, differentiation is a method used to compute the rate change of a function fx with respect to its input x. This rate of change is known as the derivative of f with respect to x. There are 6 types of techniques of differentiation. The first one is derivatives of constant, linear, and power. The second one, derivatives of sums and differences. Next, it's product rule. The fourth one is derivatives of trigonometric, exponential, and logarithmic functions. The fifth one is chain rule. And last but not least, quotient rule.
First, I will show you guys the differentiation rules. The first one is the product rule, and the next one is the quotient rule. We will start first with part A. For part A, we have y equals to 3x squared second of x plus 2. Next, we must define the u, v, u prime, and v prime value. U is equals to 3x squared, meanwhile the v is equals to second of x plus 2. Next, we must define the u prime and v prime. U prime we got 6x, meanwhile v prime we got second of x plus 2 times tangent of x plus 2. So guys, for part A, we can see the function is a product of two terms, 3x squared and the second of x plus 2. So we will use the product rule, which is dy by dx equals to u v prime plus vu prime. We will apply it to the product rule. We got dy by dx equals to 6x times second of x plus 2 plus 3x squared times second of x plus 2 times tangent of x plus 2. The final answer is dy by dx equals to 6x times second of x plus 2 plus 3x squared times second of x plus 2 times x plus 2. For part B, we have y equals to 4x plus 2 over cosine x. First, we have to define u and v. U is equals to 4x plus 2 and v is equals to cosine x. Next, we have to define the u prime and v prime. U prime is equals to 4 while v prime is equals to negative sine x. In part B, the function is the quotient of two terms, so we will use the quotient rule. When we apply to the quotient rule, we got dy by dx is equals to cosine x times 4 minus 4x plus 2 times negative sine x over cos squared x. The final answer that we got is dy by dx is equals to 4 cosine x plus 4x sine x plus 2 sine x over cosine squared x.
For question number 3, these are the question and how to solve. First, we will separate all of this number y ln 3x we will declare as number 1, e the power of 2x plus 1 as number 2, and then for y as number 3. Then we will solve one by one. First, for y ln 3x, we will use product rules because the number is multiplications. The reason I'm using d over dx and not dy over dx because we want to solve one by one and it's not the final answer. Then, we will let u equals to y and v equals to ln 3x. Then, we will differentiate u so we will get dy over dx. When we want to differentiate y, we must put dy over dx. Then, we will differentiate v so that we get 1 over x after we factorize it. After that, we will put this answer in product rules formula, which is uv prime plus vu prime, and the answer is y over x plus ln 3x in the bracket dy over dx. Now we move to number 2, which e the power of 2x plus 1, we will differentiate this equation, which the power will be differentiated, and we will multiply it in front of e, which equal to 1, and we get 2e the power of 2x plus 1. For number 3, tan for y, the formula to differentiate tan is sec the power of 2x. For y is x, then we will put our equation inside the formula, and it will be sec the power of 2 and for y. Then we will differentiate for y, and it will turn out for sec the power of 2 for y dy over dx. Then write back the equation and put all the answers below. As you can see here, we can factorize dy over dx, so we will put other number that don't have dy over dx besides. After we factorize it, we will get the final answers, which is 2e the power of 2x plus 1 minus y over x divided by ln 3x minus 4 sec the power of 2 for y.
Okay, moving on to the next question, which is question number 4. Use linear approximation to estimate the value of square root 4 of 80.99 minus 2 over square root 80.99, correct to 3 decimal places. So first of all, we have to put the equation in fx form, which is let fx equals to square root 4 of x plus 1 over square root x. In this step, we have to differentiate the fx, and then in the end we will have x exponent 1 over 4 plus x exponent negative 1 over 2. Okay, so for the next step, we have to find f prime x. So to find f prime x, we have to differentiate it again from our answer from fx. So here we have 1 over 4x exponent negative 3 over 4 minus 1 over 2x exponent negative 3 over 2. And the answer for that is 1 over 4x exponent 3 exponent 4 minus 1 over 2x exponent 3 over 2. So from the question, we know that x equals to 80.99. Now we have to find the x naught. To find the x naught, we have to find the value that is the closest to x. In this case, x naught is 81. So now we have to use the formula of delta x equals to x minus x naught, which is 80.99 minus 81, and here the answer is negative 0.01. For the last step, we have to use this formula, which is fx approximates to fx naught plus f prime x naught multiplied by x minus x naught. Since we already know that x naught equals to 81 and x minus x naught, which is basically delta x, equals to negative 0.01, we just have to put it in the formula. For f81, we just have to put in the calculation that we calculated from fx, which is square root 4 of 81 minus 2 over square root of 81. And then for the f prime 81, we just have to put in the second step of the differentiation, which is 1 over 481 exponent 3 over 4 minus 1 over 2 multiplied by 81 exponent 3 over 2. And then you have to multiply by the delta x, which is negative 0.01. For the next step, I simplify it by calculating the f81 first. So here we have 3 minus 3 over 9 and plus 1 over 4 multiplied by 27 minus 1 over 3 multiplied by 7 to 9. And then we multiply it by negative 0.01. So for this, you just have to use the calculator and type it slowly so that we don't make any mistakes. And the final answer is fx approaches 2.778.
In conclusion, the differentiation is a fundamental concept used to determine the rate at which a function changes, or in other words, its derivative. It tells us the slope or steepness of a line or curve at any point. There are several key techniques I use to differentiate various types of functions, such as power rules, constant rules, and chain rules. These tools allow us to find derivative of almost any function and useful in science, engineering, or business, where we want to know how fast something is moving or changing.